Hello, everybody. So here I'm going to do the example 1.1, sorry, 11.1 um, of our book. And in this example, we have a string coming down from the ceiling and then a cylinder attached to the string that rotates, of course, going down. And before we start doing all the stuff, I want to start marking some stuff. For example, we have a force going up. Here's the tension force of the string. And then we're gonna have instead a gravity force on the cylinder itself. Okay, and we're gonna set the y-axis to be going down, pointing down. So everything that goes down is in the positive direction. And then the center of the cylinder, which is also the center of mass, is right here. And we're gonna have delta that rotates in this direction. Okay. So now what do we have? Well, we have that the uh, change, the acceleration in this system, or y double dot, because it's along the y direction, is going to be equals to what? Well, it's going to be equals to the acceleration given by the gravity, or g, minus the acceleration um, given by the tension, or T over m. This comes from this more general formula. As you can see, the acceleration of the of our cylinder of mass m is given by the force of gravity minus tension. Because the force of gravity is going to be pointing down, or in our case, the positive direction, and the tension is going to be pointing up, or in our case, in the negative direction. So before we get into it, I want to start looking at something else first. So our torque, let me do it in block. Okay, our torque is equals to what? Well, our torque is equals to our moment of inertia times the angular acceleration for the cylinder that we have. Or, written differently, it's going to be equals to the tension. Sorry, actually, I'm sorry, no, it will be the radius crossed with the tension, but since the radius is always pointing 90 degrees, it's going to be equals to the radius times the tension. That means that if we plug it inside this equation that we have right here, I'm going to rewrite it down here. It's equals to L. Tension will then be equals to torque divided by the radius. So we're going to have G minus torque over radius times M. And oops, okay. And this means that we can substitute the torque, because we know the torque is equals to the moment of inertia times the angular momentum. So it's going to be equals to G minus I times theta double dot over R M. We know the moment of inertia of a cylinder is equals to 1/2 m capital R squared, because imagine that the radius of our cylinder is equals to R. If you want me to prove you how, I uploaded a video calculating this part right here. So I'm gonna substitute it. I'm gonna get that is equals to G minus 1/2 capital M R squared theta double dot over R capital M. So I'm gonna start by solving some of the stuff. So I'm gonna complete the set squared over here. I'm gonna get it equals to G minus 1/2, then R theta double dot. And one more thing that we can find out, that we can test, is that if we go back to our initial figure, we know that y, if we say that beginning times 0 is equals to 0, and theta 0 times 0 is equals to 0, then y is equals to r theta. It means that y dot is equals to r theta dot, and y double dot is equals to r double dot. And that is exactly what we have. Oops. That is exactly. Okay, doesn't want to do it. I'll just do it like this. That is exactly what we have right here. So I can substitute it by saying is equals to g minus 1/2, oops, 1/2 our y double dot, and this y double dot. So let me solve it one more. I'm gonna have 3 over 2 y double dot is equals to g, and then y double dot then is equals to 2 over 3 g. Okay. Now, in order to find the velocity, we can integrate our value, y double dot. So if we integrate this in terms of time, we're gonna get that the integral of 2 over 3 g dt, or simply 2 over 3 g t. Now, assuming that the plus c is going to be equals to 0, because v times 0 is equals to 0. We're starting from rest. And I can find the angular acceleration as well, because the angular acceleration is going to be equals to theta double dot. And theta double dot, we said, let's go back to what we found before. From over here, theta double dot is equals to y double dot divided by r. So let's go back. We said y double dot divided by r, so it's equals to 2g over 3r. And in order to find the angular velocity, it's going to be equal to the integral of our theta double dot in terms of t, or 2gt over 3r. Again, the initial angular velocity is equals to 0. And we can even find the in terms of actually, you know what? Let's keep it like this. This is gonna be our ending. Or sorry, I want to write it differently, which is more practical. Our angular velocity, which is equals to theta dot, is equals to 2 over 3 gt over r. And that is the end of it.